All right, welcome to Cartoon Physics 101. I'm your TA. Your professor couldn't be here today. He was on a recruiting trip. But we're going to analyze Mystique and General Nhuan.
What's the matter, baby? You don't think I look pretty like this?
The way that we analyze this is by drawing free body diagrams. So free body diagrams separate the bodies from the things around them, from other bodies in the environment, and we're going to draw the forces on the bodies and start our analysis there. So the first step is drawing the free body diagram for General Nhuan. The force due to gravity we call weight, and we're going to say that that acts on his center of mass. So we've drawn an arrow from his center of mass pointing downward. Then the force acting upwards is called a normal force. Normal as in perpendicular to the ground. And that, again, pushes upwards. And we'll say that up is our positive y direction.
Is the force coming from the wall also considered normal?
Yes, it is. That's a normal force.
Okay.
And it might be good to put n sub 2.
Okay.
In the horizontal direction, there is P. I've called it P for push. That's the force from Mystique's foot. And then N sub 2 is the normal force coming from the wall. Let's do the same thing for Mystique's free body diagram. What forces are acting in the vertical direction?
For Mystique in the y direction, you're still going to have that force due to gravity. But then are you also going to have that upward normal force as well?
Yep. We'll say that one is N sub 3, and that counteracts Mystique's weight. In the horizontal direction, there's P, that's the same force as on the General's free body diagram. And then we have F sub S. That's a friction force. The force that's pushing her in the positive x direction, pushing her to the right, is friction. So imagine if she were standing on ice or wearing a roller skate, she'd just slide the other way. So it's not that she's leaning. There's no lean force like pushing her that direction. Those are all the forces acting on Mystique. And now we need to write equations for the free body diagrams. So the way we do this is sum of the forces in the y direction, and what force is acting in the positive y direction?
The normal force, N1.
N sub 1, right? And what about forces acting in the negative direction for the general? Now we can just call force due to gravity as weight. And then those cancel each other out, or rather they equal each other. So we say that the net forces acting on the general in the y direction is 0. If there were any net force, he'd be accelerating in the direction of that force. Now for the forces in the x direction, Mystique's foot is pushing him in the positive direction, and then the wall is resisting that. So there's, again, no net force. So P minus N sub 2 equals 0. So those are the generals. Let's do the same thing for Mystique. Can anyone tell me the equation for the forces in the y direction on Mystique?
In the y direction, positive would be the normal force, N sub 3, and then negative would be the force of gravity again, or weight.
Nice. What do those equal?
0.
Right. Mystique's force is acting in the x direction. Positive is F sub S, that friction force. And what about the negative direction?
Would be the push force.
Thanks. That also equals 0. There's one more way we can analyze these. That's Mystique's tendency to rotate. So that can also happen within a 2D plane. We can translate left, right, up, down, and we can also rotate. In statics, the tendency to rotate is called moments or torques. Moments or torques acting on a body, they have units of inch-pounds, foot-pounds, Newton meters, things like that. And the magnitude of a moment is the product of the force, say in pounds or newtons, and also the lever arm. That's inches or feet. We've simplified Mystique's free body diagram to just a board, we're going to say that she rotates around her foot that's planted on the ground. We could choose any point, but if we choose her foot that's planted on the ground, there's 0 lever arm distance from the static force and n sub 3. So the magnitude of those moments is just 0, and that simplifies the analysis. So we also simplified the free body diagrams. Mystique's height is 5'10", and the human body, the dimensions of the human body are such that leg distance is half the height. So if she's doing a full split, then that split distance is also 70 inches, or 5'10". And the general, he's 5'6", and that would put his throat height at about 58 inches. You can see we've made a right triangle. To find this side of the triangle, we can use the Pythagorean theorem. That says that a squared plus b squared equals c squared. And if we are trying to find a, because we have c and b, we can rearrange this and say a equals c squared minus b squared, the square root of all that. So that's how we get a 39.2 inches. So we need a force and a lever arm distance that makes her rotate in the positive or clockwise direction. So what force tends to make her rotate in the clockwise direction?
Force due to gravity.
Yep, her weight. And what's the lever arm distance?
Would that be half the length? 19.6.
19.6. So weight times 19.6 inches. And what's the moment in the negative direction or counterclockwise? What force?
The pressure.
What's the lever arm distance from our point? The perpendicular distance from our point to that point.
58 inches.
Yep. And this equals 0 because there's no motion, no acceleration, specifically no rotational acceleration. So this equation has W and P. Marvel.com says that Mystique's weight is 120 pounds. So we have one equation and only one unknown. I'll simplify this to solve for P. See if you can do that too and get a value for P. So if Mystique weighs 120, what's the value you got for P?
I got 40.5.
Awesome. Okay. So there's about 40 pounds pushing against the general's trachea. So it turns out that it takes about 33 pounds of force to close off the trachea. She's applying 40 pounds, so he's toast, right?
Yeah, if he doesn't fight back.
Right. And so in the video, he is pushing back. I'm going to assume that he can push back with 150 pounds of force. We can think about it that he's pushing with his arms, 150 pounds of force, and he's also pushing with his trachea with up to 33 pounds before he passes out.
P becomes 183.
Yep. So if P is 183 pounds, if that's our new assumption, what does that do to W? So we rewrite the equation to solve for W, and we plug in our new P. So we plug in our new P. What's our new W?
About 540.
Right. Mystique weighs 540 pounds, and that's how she's able to basically lean against him and choke him out, even though he's pushing back. All right. Any questions?
Hey, is this Cartoon Physics 201?
No, man, this is Cartoon Physics 101. You're in the next class.
Oh.